Okay, so this next section is basically an expansion of the question of how long does it take you to reach savings goal if you are putting in a certain amount of money every year to reach that goal, right? So this is another just simple example. I'll go back up and grab these input sheets. Okay, so our setup is that you want to be a millionaire. How long will it take you? Every year you're going to put away $5,000. We'll put that in as a negative. And we want to have a future value of $1 million. And we're going to have a 6% return our investment. And the question is, what's the number of periods, right? So let's just do that calculation. So our rate is 6%. Our payment is $5,000. Our present value isn't a thing. Future value is $1 million, and there it is. 44.019 years. It'll take at $5,000 a year, earning 6% to have $1 million. So there is that. Now the next thing that they talk about in this chapter, right? So we have the interest rate is the last thing that we have not yet calculated. And we're going to leave that question to the next example, which has to do with trying to figure out what is an imputed interest rate in a lottery payout scheme. They note that you can't solve it by hand to get to the interest rate, but we don't solve anything by hand anyways. So we'll use Excel to help us figure out the rate in the next section. This is an awesome example, and it is literally a true story. Okay, in 2002, a guy won a $48 million Powerball. And after taxes, he actually got a lump sum payout of $17 million. Right, so they said it was $48 million. But after taxes, it was $17 million. How the heck does that work, right? How does that work? Is because what they do, right, is they announce the value of a lottery as the sum of the annuity payments. And in this case, it was going to be $1.9 million before taxes over 25 years. So let's just verify, right? See, the annuity payment was 1920000 for 25 years. Okay. If you multiply, let's just verify the lottery advertisement. So 25 times 1.9 million is indeed $48 million. Okay. So the thing is that what we want to know is, was it a good deal to take that lump sum payoff of $26,000? Okay, so the lump sum payoff was 26,072,769. Okay, so that's what he took, and then of course he had to pay taxes on it. $26 million all at once. What's he going to do with it? And so the question is, what is the implied rate of interest when you've got a payment of 1.9 million, time period of 25 years, the rate is unknown, and the present value is 26 million. Okay, so let's figure that one out. Now, when you are solving for a rate, okay, you can't directly calculate that by hand. You have to let Excel kind of run its thing, do some iterations of guesses because of sort of the way that the equation is. It's not possible to just close the solution in one go. But that's okay because we have Excel for that. So we've got 25 years. We've got a payment of 1.9 million. Let's take the negative of that. We've got a present value of 26 million. And we could give it a guess. We could start it with 0.05 as the guess at the end of it, but because it's inside of these square brackets, it's not technically necessary to include that argument, so let's just go ahead and hit enter and see what it gives us. Okay, so it's 5% return. I want to also note 5.37% return. I want to show you what happens if you forget to use the negative here, because I know some of you are going to call me with this question. All right, you get an error message because you have to have, in order for these to work in Excel, you have to have a negative on the payment or one of these elements, right? So if we just make this directly, make it a negative, that'll work as well. So 5.37%. So we calculate the 5.37% return. Now, what does that mean? Okay. It means that what's implied in this annuity setup from the lottery, that this present value is earning a 5.37% rate of return if it will give you an annuity payment of $1.92 million over 25 years. Is that a good rate of return? It depends. We'll talk a lot about what's a good rate of return in later chapters. But what would he be able to do if he was able to invest in an 8% investment profile rate of return? How much could he take every year for 25 years? Right, so right now, this 26 million, if it were earning 5.37% interest, would allow him to take an annuity of 1.92 million for 25 years. Right? What if the rate was 8%? What would the payment be? Okay, so let's figure that one out. So let's say our rate is 8%. Everything else is as above, so let's figure out the payment. Here's our rate, our 25 years, our present value of 26 million. Right, so if he were able to invest at a rate of 8%, then he could take out annuitized payments for 25 years of basically $500,000 more. Which is why, in this case, it might have made sense for him to take out that lump sum payoff. Now, are most people able to do that? No. What happens to most people who win big lotteries? They're broke in a couple of years. But from a financial standpoint, in this case, it probably would make sense to take the lump sum payout, although you're not starting with that whole 26,000, you're starting with the after tax. So let's say it was 17, because that's really all he's left with. Can't remember what the 17,729. 483 after taxes. So at that point he can only take a payment of 1.6 million. But of course his annuity payments would have been quite a bit lower than 1.9 million after taxes too, right? So it always has to be an apples to apples comparison. Anyways, that's the lottery issue. Now, I will leave these to you because we've gone through them and I don't want to repeat myself and bore you with long lectures. All right, but this is basically it for the time value of money. And what we're going to do now, I'm going to take you through how to do a few of the example problems. I've given you a practice problem set with infinite check my works. So, you can work along with me for some of them and give that a try and then do your homework.